Hello and welcome. In this video, we will design the geometry for the inner gear. So now let's go to modular here and select coordinate system and create relative coordinate system in both directions. So I will uh, add here relative coordinate system like this, and for the origin here sorry, let's select the global coordinates here, and in x direction I will add diameter of large gear, inner diameter, minus air gap, which is 1 millimeter in length. Here unit type is length, and air gap is equal to 1 millimeter, and sorry, this inner diameter is divided by 2, and minus air gap, and then minus the outer diameter of the inner gear divided by 2. So we can here select the diameter of large gear and divide it by 2, and then multiply this 2 with 5, which is the gear ratio. Okay, and then click OK. Sorry, this should be in the origin here for x-axis, and here I will put for x-axis 1, 0, and 0, and for y point I will put 0, 1, and 0, like this, and click here OK. Now this is our new coordinate system that we will define the inner gear relative to it. So let's draw like we did in the large gear. Let's draw the geometry for the inner gear around this new coordinate system. So I will go here to draw and select cylinder here. Sorry, select cylinder from here, and make this outer diameter for this cylinder is equal to the diameter of the outer diameter for the large gear divided by 2 multiplied with the gear ratio, and the height will be same of the large gear, and here we can add height of the large gear divided by 2 as shown here, and number of segments will be also equal to 100, and click here OK, like this. Now let's take this as copy and paste here, but in this time we will put here the inner diameter for the large gear as shown here. But in this time we need to keep the width as the same, so I will keep it as outer diameter and subtract 2 millimeter from this as shown here, like this, so that the width of the magnet will be the same for the large gear and the inner gear. Now let's subtract the small cylinder from the large cylinder, like this. Go to edit and then Boolean and then subtract as shown here, like this. Now like we did in the geometry definition for the large gear, we will do also the same for the inner gear. I will draw a box here this box height will be same of height of large gear, and here minus height of large gear divided by 2. And for exercise we can put here diameter of outer gear multiplied by 2, and here here large diameter of outer large gear outer diameter divided by 2 multiplied by 5, which is a gear ratio, and we can multiply this with 1.1 as shown here like this. And for the Y size, we will keep the distance between magnets same as 2 millimeter, and here we can put minus distance between magnets and divide this by 2 like this here. Now let's duplicate this around Z axis, but this time we will put 4 here and divide 360 by 4 like this, and we can subtract all these boxes from this cylinder like this here. And after that we can go to edit and click on Boolean and then separate all bodies like this. Now we have 4 magnets. We can select 2 of them and give them a color of blue color, and the 2 others will be or will have red colors like this here. Okay, now we need to insert also or add the back iron for this inner gear. So I will add it here like this. Also the height is equal to height of large gear, and here minus height of large gear divided by 2. And the radius will equal to diameter of large gear divided by 2 and then multiplied by 5. Minus 2 millimeter, and then minus 3 millimeter for the back iron width. Okay, and then we can add here. Okay, sorry, we need here to add millimeters. Sorry, we should put 2 multiplied by 5 like this here, and click OK. Oh, sorry. This is a small cylinder. We will also draw same cylinder, but without this 3 millimeter, and we can subtract the small one from the large one, as here go to edit and then Boolean and then subtract. This is the small one and this is the large one, and click here OK like this, and give the result a color of gray color as shown here. Okay, now we have here 4 magnets. These 4 magnets should be oriented relative to coordinates called relative CS1. And also the back iron here is relative to CS1 coordinates. And now we got the geometry definition for the inner gear also. In the next video, we will define material for all of these elements, and after that we can define the band for defining the moving definitions for the inner and the outer gear, and finally we'll define the boundary and get all reports for torque and plot magnetic fields. So I hope that you like this video, and see you in next videos.